Hi there. Today, in this lecture, I'm just going to work some examples like the section 4.10 on antiderivatives, like the homework. Okay, so let's look at our first function. And what are we trying to do? We have the derivative, and we want to find the antiderivative of the sine of pi x. Now, we haven't learned a technique for this called U substitution yet, so we go back to that table and just refer to the formula. So I know the antiderivative of sine is the negative cosine, because if you look at this, the derivative of the cosine is negative sine x, right? So the derivative of the negative cosine would be positive sine of x. So that's where that formula comes from. And in that formula, we have to figure out what k is. Well, in this case, k is pi, and 1 over k would just be 1 over pi. So the antiderivative looks like 1 over pi, the negative sign out here, cosine of pi x. Now remember, we can always check our answers, well, almost always, by going back the other direction now. If we take the derivative of the antiderivative, we should end up with what we started with. So let's carefully try to do that. So I'm taking the derivative of this function to check to see if I really do get sine of pi x. Okay, well, when we take the derivative, the constant just sort of stays outside. The derivative of cosine is negative sine. Leave the inside function alone, that's pi x. And then don't forget from the chain rule to multiply by pi. And when we simplify that, you could see that the two minus signs cancel out, and the 1 over pi cancels out the pi. So yes, indeed, I am left with sine of pi over x. Now, what can get confusing is which direction you're going, especially in the beginning. So just be very clear what you're doing. We were finding the antiderivative of this function. And then to check, we took the derivative of the antiderivative. And that gave us back what we started with. Okay, let's try another one. Here is the formula that we need. So in this case, k, if you rewrote this function, let's do it in red. If we rewrote this, this is actually 1/5 times x. Sometimes that's not clear when you just glance at it. But now I can see that k equals 1 over 5, which means 1 over k equals 5. And now I'm just going to use this formula for finding the antiderivative. So that will be, we still have this 5 out here. Now the antiderivative of cosine is sine. Whoops, I left off my 1 over k. I need 1 over k, which is 5, sine of kx, which is just x over 5. And we're not worrying about the plus c because we're just finding any old antiderivative. What does this equal? 25 times the sine of x over 5. So let's check. Let's take the derivative of that function. Okay, so well, the constant just stays as 25. Derivative of sine is cosine. Leave the inside function alone. And then don't forget from the chain rule, I need to multiply by 1/5. And if we simplify that, you can see that this 25 multiplied by 1/5 will give me what I want. 5 cosine of x over 5. Okay, so you have a couple of problems like that. And then we have some like this, where we're asked to find the most general antiderivative. So we will add a plus c to our final answer. Now, this is a product. We have no rule for finding the antiderivative of a product. So we have to multiply this out. So I have 2x times 1 minus x to the negative 3 power. Well, that will equal 2x times 2x times x to the negative 3. And then we just simplify. Remember, there's a 1 here, and when we multiply, we add exponent, so this is 2x to the negative 2. Now, look what we can do. Now, I know how to find the antiderivative of that. We will use the power rule. Increase the power by 1. And divide by the new power. Okay, so where does that get us? Well, we'd have 2x squared divided by 2 minus 2x. Now be careful with negative exponents. We're adding 1 to negative 2, so that turns it into negative 1. And then we divide by negative 1. And yes, of course, we want to simplify this. The first term just becomes x squared. That minus sign turns into a plus sign. And I'm going to leave it with a negative exponent because that'll make it easier for me to check my answer. So let's check this. Is this the antiderivative? I can take the derivative of that function and hopefully end up with this guy. So what's in here? X squared plus 2x to the negative 1 plus c. Well, the derivative of this would look like 2x minus 2x to the negative 2 plus 0 if you want. And yes, we have what we wanted. All right, one more. This one looks really fun. So how do you handle something like this? Again, we don't have a rule yet for finding the antiderivative of a quotient. So you have to get clever, and we will rewrite the integral. This is something I've been emphasizing throughout the course. So first, I'm going to just split it up. This is a legal move. And now I can simplify each term in this sum. The first one will be 4 over x squared. The second one, well, maybe that looks a little confusing, but definitely I can cancel one of those x's. I still need to be able to rewrite this because I have 4x to the negative 2. That's good. I can put that up here. I know how to find that antiderivative. But what about this? Well, you have to remember your exponent rules. X to the a over x to the b is x to the a minus b. So what do we have? We have x to the 1/2 over x squared. That's another way to write that. So that would be x to the 1/2 minus 2. So that becomes x to the minus 3/2. And now I've turned it into an expression that we know how to find the antiderivative of. So this, let's be careful, we have 4x to the negative 1 divide by the new power, negative 1, plus, okay, if we increase negative 3/2 by 1, I would get x to the negative 1/2, and I have to divide by the new exponent. And we're going to simplify this, and then I'll add on my constant c. So that gives me negative 4 x to the negative 1 minus 2 x to the negative 1/2 plus c, which I would probably write like this. But if I want to check it, I'm going to check it using this form. So let's double check, because it's kind of hard to tell. So let's take the derivative of that thing. Negative 4x to the negative 1 minus 2x to the negative 1/2. I'm going to ignore the c because the derivative of any constant, this is just a number, remember, that would be 0. So what would this derivative look like? Well, negative 1 times negative 4x to the negative 2 times, well, this minus 1 comes down. It will cancel that negative sign, so we get plus, and the 1/2 times the negative 2 is 1. Decrease 1/2 by 1, you get 3/2. Now, is that our integrand? Whew, yes, it is. All right, so this is my answer. Okay, now if you have questions about some of the homework problems, they're a little tricky, some of them, feel free to ask. And I'll talk to you soon.